corresponding and alternate interior angles are formed when you have two parallel lines that are cut or intersected by a transversal. Okay, so that's the line going across those two parallel lines. So if we look, we kind of have two sets of angles. So before, when we had talked about this, we can also have vertical angles. Okay, like 8 and 6 would be vertical angles, 5 and 7, 1 and 3, 4 and 2, and then we have adjacent angles. Now, for corresponding angles, these are angles that, if you want to think about it, are in the same place. So we have one angle from this top set, one angle from this set. Which ones are in the same position? So if you look at 1 and 5, they're both in the top left. Those are corresponding angles. Think to when we're talking about similar figures, okay? That we're looking at corresponding sides. Which side in your small figure matches with the side in the larger triangle, or even in congruent shapes, okay? Which ones match? Which ones go together, okay? 1 and 5 are corresponding. We also have angles 2 and angle 6 are corresponding. They are both in the top right. 3 and 7 are in the bottom right of their sets, and 4 and 8 are in the bottom lefts. Okay? Now, we also want to look at alternate interior angles. So with interior, we're talking about angles that are in the interior of the parallel lines. So it's between these two parallel lines. So the only angles it could be are 4, 3, and 5, and 6. With it being alternate interior, we want alternate sides of that transversal. So 5 and 3 are alternate interior angles. 4 and 6 are alternate interior angles. Now what's special about both of these types of angles is that corresponding angles are congruent. Angle 1 is congruent to angle 5. Angle 2 is congruent to angle 6. The same thing works with the alternate interior angles. Angle 4 is congruent to angle 6. Angle 3 is congruent to angle 5.